Today we are going to look at a very simple but logical question on logarithm. As you know, logarithm generally deals with laws. So anytime you encounter the question in logarithm, always think of one or two laws to apply that will enable you to obtain your results. So let us see what we have here in this question. We are given that log a over b minus c is equal to log b over c minus a equal to log c over a minus b. We are asked to prove that a raised to the power a, b raised to the power b, and c raised to the power c, the result is 1. So how do we achieve it? So always know that logarithm, if the base is not given, is always in base 10. If I have log a now, it's not just log a. What is the base of this log? It's always in 10. Log, I can rewrite it as log a in base 10. So every log given to you without the base, always take the base to base 10. That in general base of logarithm. So this expression, what I will do with it, since they are equal to each other, I will equate it to a constant, maybe k or c, any constant. But since we have seen the expression, let's use k as our constant. So I will say log a in base 10 over b minus c is equals to log b in base 10 over c minus a is equals to log c in base 10 over a minus b. Let's call the constant k. Why are we using k? Because we already have c in the expression, which is this c here. So there's no need using c so that we don't get confused. So I have to express each of them. Each of this expression is equals to k. That means I will say log a in base 10 over b minus c is equals to k, comma. And the same is also true for the second expression, log b in base 10 over c minus a is equals to k. The same is also true for the third expression, log c in base 10 over a minus b is equals to k. So what happens if I have to make the log a in base 10 the subject formula? So let's make log a in base 10 subject formula. So my log a in base 10 will give us k into b minus c. K into b minus c. Let's call this one equation 1. The same is also true. Let's make log b in base 10 the subject formula. If that should happen, I'm going to have log b in base 10 is equals to k into, what do we have in the denominator? We have c minus a. So we have c minus a. Let's call this also equation 2. And lastly, log c in base 10 is equals to k bracket. Let us see what we have in denominator, a minus b. A minus b. Let's call this equation 3. So let's go back to the question. You look at the question, we have a raised to the power a. We're trying to look for a raised to the power a. That means I need an expression for a, I need an expression for b, and I need an expression for c. So I will simplify this expression and see if my result will be 1. So what do we do from here? What happens if we say add? Let's add these 3 equations. Add 1, 2, and 3. Let's add the 3 equations. If we add them, what are we having? We are going to have log a in base 10 plus log b in base 10 plus log c in base 10 is equals to k brackets b minus c plus k brackets c minus a plus last one k brackets a minus b. So respectively, each of them represent the value of log a, log b, and the log c. So if I apply the law of logarithm, let's say what the law of logarithm says, where you are adding two logarithm with a common base. Let's recall that log a in base 10 plus log b in base 10. The law says, if you have a situation like this, classify the logarithm and the base as 1, where you multiply the power. So I will have a single log in base 10, which is now a times of b, which can also be written as log in base 10 ab. A times b will give us ab. So let's see how we should apply the law in this regard. Let's apply the concept here now in this regard, because we are adding three logarithms, but they have a common base. You can only apply this law here if the bases are the same. That's the only condition you can apply the law. We satisfy the expression that we have. So let's take the logarithm as 1 while we multiply the powers. But if you look at my right hand side, you can see we have k as a common factor. Let's bring out the k as a common factor from the right hand side. So we're going to have log in base 10 a times b times c equals to k into, I'm bringing out my k now as a common factor. I'm having b minus c, c minus a, and a minus b. So I'm having b minus c plus c minus a plus a minus b. I should factor out k from the expression. So my right hand side will give, my left hand side, sorry, will give me log in base 10. So I multiply these three things. I'm having a, b, c. So here will give us k into, I will cancel out those like I cancel out. Minus b plus b is 0. Minus c plus 6 0, and minus a plus x 0. We are just left with 0. As we all know, bracket means times. So k times 0 will simply give us what? 0. Let's also equate or quote a law of logarithm that says, we have another law that says log a in base 10, for instance, if log a in base 10 is equals to c, log a in base 10 equals to c, to find a, I'm looking for a right now, which is this a. The law say whatever I have here should raise this. So my a becomes what? 10 raised to power c. So let's apply the law in this regard, in this expression now. The logarithm of a, b, c in base 10 is equals to 0. So let's apply the law in that regard. We are going to have a, b, c is equals to 10 raised to the power of 0. ABC will give us 10 raised to the power of 0. And we all know from indices, we are told in indices that a raised to the power 0, the value is 1. That means 10 raised to the power 0 is 1. So I'm having ABC is equals to 1. Now, so we have three alphabets here, ABC. Let's try to get the individual factor or number. So I could say ABC can also be written as 1 times 1 times 1, not to change. So that I can get the value for A, for B, and for C. 1 times 1 times 1 is the same thing as 1. It therefore means that my A is equals to 1, my B is equals to 1, my C equals to 1. So that, let's now go back to the proof, what we are asked to prove from the question. We are asked to prove that A raised to the power A times B raised to the power B times C raised to the power C equals to 1. So let's put in our expression now and see what we arrive at. So a raised to the power a times b raised to the power b times c raised to the power c, so the result is 1. So let's fix in our value. So before we do that, please remember this is Sum Up Africa. Like our videos, subscribe to it. I also recommend it to friends where you see exciting videos such as this. So let's continue with it. So my a is 1, my b is 1, my c is 1. So we're having 1 raised to the power 1 times 1 raised to the power 1 times 1 raised to the power 1. If simplify it, we're having 1 times 1 times 1, which is what? 1. So we're having QED. will obtain the quantity of the equation demanded at the end of the day, QED. So if you like what you are watching, like I said earlier, subscribe for more exciting video on STEM Up Africa. See you next time. Thank you for watching.